So, who wants to go first? Yes. Which one do you want to tell us?
Abstraction.
Okay, so abstraction. Mr. Chan. Yes, sir.
It is a conceptual process where general rules and concepts are derived from the usage and classification of specific examples.
Say that again.
Use of examples.
No, like everything from the beginning.
A conceptual process where general rules and concepts are derived from the usage and classification of specific examples.
Okay. Any other who wants to add to that? What you have found? Yes, Leo?
So, is the process of extracting the underlying structure, pattern, or property of method concept.
But that's not complete. Read that from the beginning.
Abstraction mathematics is the process of extracting an underlying structure, pattern, or properties of mathematical concept, removing any dependence on real-world objects.
There's a reason for that additional part.
Have been connected.
Because I also put that definition in the note for you. Karen, what do you have for us on abstraction? Same thing. Any other thought different from that? Okay. Yes, who wants to go to the next one? I'll project something for you, then we can go into conjecture, please. Anyone? Conjecture?
A conjecture is a mathematical statement that has not yet been rigorously proved.
That is yet to be proved? Is any other thought on that? Millennium prize problem. I was going to show you something. Yes. That's all everybody, you agree with that on conjecture? Okay, hypothesis. Yes, Karen. You raise your hand, right?
Sure.
Oh. No, I thought you raised your hand. You were just doing it. Okay. Well, you are arrested anyway, so.
Okay. Is a proposition that is consistent with known data but has been neither verified nor shown to be false.
It's not verified. It's a proposition. I love the word proposition.
What does that mean?
Proposition, like something you.
I just said okay.
Okay, she's fine. Any other person on hypothesis? Okay, let's go to proof. What is a mathematical proof? Yes, Leo.
A logical mathematical argument used to show the truth of mathematical statements.
I think we even have a better line than I wrote there. So that's good. Can you say that again? I love that one.
Logical mathematical argument used to show the truth of mathematical statements.
When we say the truth of a mathematical statement, does anybody know what that means? I'll start from there.
The logic is correct.
Or
The argument?
or not. When we say the truth of a statement, it doesn't have to be the word true. Okay? That's why I thought of, what I just said now about something I learned in my polytechnic days. There's something we call truth value, and we have something we call the truth table. And I think that will lead to, maybe we start with, let's go to the last one first. Types of mathematical proofs. Which one do you find?
Direct proof.
Direct proof, okay.
Proof by mathematical induction.
Proof by induction, which is something we are trying to get at today. Yes?
Proof by contraposition.
Contraposition?
Yes. And then there's also
Contradiction.
Okay.
And
Okay.
by construction, by exhaustion, and then probabilistic proof, combination proof, non-constructive proof.
A lot of proof.
There's so many.
Well, the most important one we'll be looking at proof by induction, we'll be looking at proof by counterexample, we'll be looking at the exhaustion one. I'll check your syllabus. I will just restrict it to those ones only. Okay? Now, I was saying something about truth value based on what the argument, the definition Leo gave us. back in the days when, after my high school, I studied statistics and math in a polytechnic back home. And I can remember one of my favorite courses then was logic and linear algebra. And in the logic part is to expose us to some of these ideas of proof. What are implications? What is an antecedent? What is consequent? You remember those two? There was a time I asked you to check antecedent and consequence before we started the class. Do you remember that? So those were explained. Now, and one of the things that I still head on to today is the idea of the truth table and, of course, connectives. Now, P and Q are statements. P could be all boys are very playful. Well, I think that's a fact, right? And Q could be, what do we say about girls? All girls are very quiet. We know that is not true.
All girls are very playful.
All girls are what?
All girls are tired.
Okay, let's say all girls are. Let's use the same statement. Okay? Now, there are two different statements, but this is about boys, this is about girls. Now, what is this always true? No. Then we say the truth value of this is false. Is this always true?
Yes.
No. No! We have some playful girls and we have the quiet ones. I have a quiet one here and there. Well, they are quiet in my class. Okay? This is also false. But look at this statement. Do we have, all roses red?
No.
Even that is false. Oh, I thought that was true. Yeah.
No, there's
White-
white.
White rose.
Yeah.
I once gave someone a white rose. Don't ask me who.
Well, it's a hard one.
Don't ask me who.
Who? Roses are red. Fine.
Apples are red.
Not all apples are red. We have green
Green
apples. I'll be surprised to get somewhere and there are black apples.
Mr. Daniel is handsome.
Really? That is not a true statement to some people. Alright, let's be serious now. Let's think of something that is always a fact.
SON is in Macau.
Thank you.
Me? No.
XON is in Macau. For this statement, the truth value will be T. So that's the meaning of truth value. It doesn't have to be the word truth that you know. Okay? You can make a statement, but a statement is different from a proposition. A statement will have a truth value. A proposition does not need to have a truth value. You're only proposing this idea. It doesn't have to be, you know. You get my point? Something like that. Anyway, now, abstraction in maths. Maybe it's high time I give you something that I was thinking of. Can somebody put on the projector? I'll show you this. I will explain with this note that I've put down for you. Quickly. Let's start with abstraction, conjecture, hypothesis. What is a proof? What are the components of a proof? What are the types of proof? And then we can go to connectives from there. The front lights, Karen? Just the front one alone. She's too lazy to get up. Yeah, I think we can see the board. And check the camera also. Come and see that.
That's kind
Or
of.
maybe we turn it off.
Wait, turn off which one?
You're not afraid of the dark, are you?
Ah.
Is it better? You may not see how
It is.
someone will see it. So. Is it
There's
better?
something, but
Yeah, okay. But don't worry, I'll probably just send a note to Nakita later anyway, so. We'll send it, Nakita. Well, as if she's watching it live. Okay, so this is the definition you gave me, Leo. And I use this definition also because it has everything that I need in it. When you're trying to make an abstraction of an idea, it's an abstraction. It's not meant to be something that you can easily connect with. It's something that has to do with your critical thinking without actually maybe stating an example. For example, I once told you when you are proving something, you prove in abstraction. You prove in general. You don't prove with specific example. Okay, that's a basic idea of what abstraction is about. You are talking about, the sum of three consecutive numbers is divisible by 3. We are not asking you to pick 3, 4, and 5, add them together, and check if it is divisible by 3. We want you to put that statement in form of an abstract, use letters which can represent anything, and see if that statement is true. Do you understand that? So that is why this line was included, removing any dependence on real-world objects. Removing any linkage to specific situation and come up with a generalized idea, that is an abstraction. Why is this important? Most of our proofs are in form of that. Your proof in math is not meant to be, because he did something like that yesterday, I saw it in his house, so everybody has Netflix because he has Netflix. You are being specific now. It's possible you move to the next door and that person does not have Netflix. Then you are wrong. But if you come up with something like, let A be someone, and you can show that that someone without name has Netflix, then if A assume the name Callista, then you have already proved Callista has Netflix. If A assume the name Leo, then you already proved, because A could be anybody. Does that make sense? We call it arbitrary. Actually, one of the statements will say, because A is arbitrary, because A could be anything. That's what it means. And since I have proved for anything, whatever example you bring in will definitely work for it. But the other way does not always work. Conjecture. When you consider some examples of some things and you make a prediction, that's a conjecture. You consider, when n is equal to 1, maybe you are working towards a sequence when n is 2, when n is 3, and you say, which means when n is k, this is what might happen. That's a conjecture, but it doesn't mean you are actually, that thing is true. What was your definition of conjecture again? Somebody mentioned something that I said I love. I think that was you. Can you read it out again? Yeah. Was it you? Conjecture? Was it Leo? Was it Karen? Let's hear what you said about conjecture.
A mathematical thing. Wait, no.
No. Can you read what you said about conjecture?
Okay, I think we have the same one.
I want to show you this.
This one hurts.
Have you guys heard about the Millennium Prize problem?
Yes, you talked about it.
Okay. So I want to, yes or no? Let's just move from there. Look at this. Well, there are 7 of them, so 6 are still unsolved. What do you notice here? Conjecture, conjecture, conjecture. Some of this problem I do not understand, actually, because even the world-best mathematicians are still working on them. And of course, there's still $6 million prize at stake. What's going on? What did you do wrong? Someone is trying to hack into our system.
Wait, what is the first thing called?
What did I press? Oh, okay. That wasn't me. I was
using that curse.
Anyway, so each of these, there's still a bounty enterprise, or is it bounty now, of $6 million on them. Only this has been done. And I heard the guy who later solved it decided to reject the prize. If I still remember the story correctly, it's like maybe Ethan was doing something and after reading what he did, that gave me an idea on how to solve it. And I was going to be given the prize, but I'm rejecting it because I need him also to be recognized, because without his work, I wouldn't be able to have done it. So he rejected because the other person will not be recognized. Only he will be recognized. So I don't know. If maybe after that something has been done, maybe he has accepted the prize. I have no idea. But that was maybe in the mid 2000, maybe 2005. I read it, or maybe 2008. I can't remember. Okay. Anyway, my point is, this from the word conjecture. Somebody must have maybe looked at something. Oh, when you do something on the computer, this happened. Can we now assume this will happen? You consider few situations, few scenarios, and you assume something. That's conjecture. But it doesn't mean it is true. Okay, conjecture needs to be proved before it becomes a fact. Does it make sense? We don't know what the future holds. One of you might end up solving one of the remaining 6. We don't know what the future holds. Now, a mathematical proof, like you said, establishes the fact. What does it contain? An assumption, which is your hypothesis. You do some of these things indirectly. When someone asks you to solve a linear equation, you start with an assumption. Let X be the age of the student. That's an assumption. And at the end, you follow some logical steps, isn't it? Then you have a conclusion and say, oh, therefore, the student is 10 years old. I'm just bringing it down to middle school level now. So a mathematical proof is like that. There will be an assumption. Look at the one of the proofs that I gave you before at the beginning of the term. I asked you to prove something about a number. Then I asked you must prove in general. Do you remember that? By assuming that, by using letters to assume, that is your hypothesis. In some situation, you will be given some fact in the question. That will be the beginning. Oh, suppose this hold. Okay, suppose this happens. Then you follow through, and at the end of the day, you have a conclusion. Your conclusion might be that that hypothesis is wrong. We will talk about that and prove by contradiction. For example, you start by saying, so there's a popular proof that square root of 2 is irrational. Yes, prove that root 2 is irrational. You might be wondering, but everybody knows it's irrational. Why do we have to prove that? Okay? And the first thing that people, the popular proof that I know, people do is, suppose root 2 is rational. Do you understand? We are assuming that we know it is not rational. Okay? But one of the ways to prove is to use contradiction. You start with a statement, you try to work towards that statement, and at the end of the day, something doesn't make sense, then you now conclude that, oh, I must have assumed wrongly. Then you state the opposite of that statement. That is a proof by contradiction. So if you start by saying, suppose root 2 is rational, then you say, oh, that means I can write root 2 as a over b, because the definition of irrational means you can express it as a fraction. Do you understand that? Then you can say, oh, it means 2 is a squared divided by b squared. Okay, then this will continue. I think it will be a squared minus 2b squared. We're going to need some factorization at some point. Maybe. No, wait, what's this? Okay, because 0. Then, how do we do that again? Let me see. A squared minus 2b squared is equal to 0. Then, I can't remember how we did this. Okay, let's see. Anyway, my point is, when this continues, you are going to end up, I'll try to remember it maybe during the class, and I'll show you what I'm trying to do. Or this might even be one of the questions we will do when we get to prove by contradiction. Alright? So at the end of the day, we end up getting something that doesn't make sense. And the conclusion will be, oh, this must have been wrong. Then you now give the opposite of this statement, which is something we call negation. We'll talk about that under connectives. Do you understand what I mean? So, it's a logical proof we follow this order. It will start with an assumption, called an hypothesis. It will follow logical, I said a logical sequence of correct steps. There's a reason it must be logical. There's a reason it must be sequential. You cannot jump from one step to another. Does that make sense? You cannot jump from maybe 1 to 7. Oh, 1 will link to 2, 2 will link to 3. For example, in this incomplete proof that I'm trying to show you, this leads to this. Everybody knows why. This leads to this. Everybody knows why. This leads to this. Everybody knows why. I won't jump from here and just write something here. It has to be sequential. Or I write from here to here, my next step is this. You know, that's not in sequential order. Miss, everything alright? Sit up. Okay? Also, your math proof could contain a logical calculation. This contains some calculation because I'm doing some square, factorization, cube, and whatever, right? In some other, it could be just reasoning and telling us, oh, if this happened, then this will happen. Oh, if this happened, then this will happen. I'll show you something from your textbook. If I can quickly project that. That will be page, it's an open problem. I don't know my password. Let's see. I don't memorize those passwords. Let me see what it's good. Oh, okay, here is it. Thank you. I don't like stressing my brain too much. I need my brain for something else, not stress. Yeah, look at this problem. A group of people are involved in a business meeting. Alice looks at Bob, which is not a crime yet. Bob looks at Claire, which is still legal. Alice is married, but Claire is not. Think about this. Do we know whether Bob is married? We don't know whether he's married or not, right? Okay. Can we prove that a married person looks at an unmarried person? How, Leo? Can you prove from this statement that a married person looks at an unmarried person? Is it a fact you can establish? Don't say yes or no yet. Think about it. Anyway, the third one is what is necessary for a mathematical argument to be convincing and complete? Can I ask you to look at this situation? Oh, there are 3 people. The third one is ID. Where are you, Claire? There you go. Can I ask you to look at this problem? I give you 2-3 minutes and see if you can prove, question B, can we prove that a married person looks at an unmarried person? Or maybe the other way. It could be that, oh, a married person looks like a married person, unmarried look at unmarried, or maybe married looks, there are 4 possibilities here. Which one can you establish? You can, restrict it to this, or you can say, oh, we can't prove this, but we can prove that. 5 minutes, think about it. You want to stop the recording because of the battery?